Hello everyone. Thank you for giving this course. This week is week 7. I just graded homework 1. If you have any problem with the grading, please submit a request and we will read it. I will also put the solution to homework 1 on the blackboard so that you can get a look at how the correct answer should look like. For this lecture, we are going to basically looking at two stuff. The first part will be me presenting some relevant background on BERT model. The second part there will be a student. Somehow she's currently not here. She will be presenting a relevant paper on BERT model. So, what is BERT model? BERT is a shorthand for bidirectional encoder representation from transformer. So it was released by Google in 2019. Basically, they found that doing the transformer to predict the sequences step by step, it may not be the single solution of modern languages. So in that paper, they say that they propose a neural language representation model called BERT, which stands for the bidirectional, which say that you can do sentence from left to right or right to left. So you get two directions. And then it is an encoder. Basically, it will encode sentences into a representation. So the second sentence is saying that it is different from the reasoning language modeling. It is going to design a pre-trained model that we are going to pre-train on the human text. And then it is a bidirectional representation from unlabeled text by conditional left and right context in order. Basically, the context is if it's a left word. So if in the previously, if you have some word W1, W2 to WT, then this is called the context. And what is this context used for? For predicting the word of WT plus 1. Now we are doing a bidirectional order. So you also have this is a left context. Now you also have the right context. So what is the right context? So the right context should be something like something here. This is T plus 1. So we got right context, T plus 2 to W capital T. If you left context, then you're going to read those sentences from left to right. And if you right context, you're going to read it from right to left. And then this is saying that given the left context and right context, we are going to predict the middle word. So, how to model it? Basically, this is the BERT modeling. So you've got some input sentences. The input sentence is the beginning of some sentences. And then this is the input word. Let's stick to improvisation in this skip. It will be processed by randomly removing some word. For example, this word is removed. And what is the task? The task is to predict the accurate probability of this word. So you got some models that are going to read this sentence from left to right, and also from right to left. So this is the word to be predicted. And then you are going to predict the fifth word here. And then you're going to maximize the probability of the correct word. And what's the difference between the BERT model and the existing transformer model? The first paper proposed in the transformer paper is saying that we need some encoder and decoder. Encoder is saying that we can encode the sentences, encode a sequence of words into some embedding. And then decoder, depending on the task at that time, the task is to machine translation. You're going to translate from English to Mexican sentences or from English to French sentences. So encoder is nothing but reading all the English words step by step, and then it become a later representation. Decoder, the task is to maximize the probability of your, for example, if it's a Mexican sentences, then it will be maximize the probability of the correct translated Mexican sentences. Decoder only later will find very effective using which was used in GPT and ChatGPT model, which is saying that we no longer need some encoder module. We only need some decoder only module, which is saying that so now it had so the encoder previously was used to read some text, and then the decoder was to output some text. And then the decoder only is saying that I'm going to remove all the encoder module and then going to use the input to the system as some prompt. So now we have some like prompt driven language modeling where the decoder only going to read the fixed beginning sentences and then going to predict the follow-up sentences. If you want to still do the machine translation task, then it is saying that the decoder only will first reading your English sentences word by word, then going to predict the Mexican sentences word by word. Now, what's the benefit of having this decoder only model? Now you'll find that I have less parameter. So if you have less parameter, then it will be easier for the model to train. Encoder, now this first model is saying that I'm going to now this is decoder only, now this is encoder only. Encoder only is saying that I'm going to, for the sentences, I'm going to dig some hole in my sentences and replace it with some like empty word called must. And then I'm going to predict the probability of those those slots, and then maximize the probability of the correct word. So there are a lot of follow-ups to this Earth research. One thing that was let's see. One thing that was shown to be effective in the experiment, they find that how many masks do I have to be so that my experimental result is strong. So they find that they can randomly remove like 50% of the token so that the model can learn a good representation. Now, my question is, does it necessary to be 15%? How about I like do some random mask, like from 100% masking to like 0% mask? Can you think about some extension to this BERT model? So in their experiment, the paper released by Google, they say that 15% of the mask is effective. So do you have any like generalization saying that only this must be 50%? Can this be like 50%, 70%, 90%? What does it imply that you have like 90% of the masks?
If you have 90% of the mass, there's not as much context for them to work with. So it might be less accurate
Yeah.
at the beginning of these.
Yes. Yeah, that's a good answer. And any other one want to guess? Like, so if you got like a lot of places are masks, may want to predict the correct word. How do you utilize this weapon to make it more effective? So here are some like graphs that you can think about. Can I keep playing it? Yeah. So this is some like diagram that people find it more effective to do this vector modeling. So you find those words does not necessarily go from left to right, right? It somehow pop up here or pop up here. and then those empty places, you can think of it in each picture, it is mask. And it's saying that instead of directly doing language modeling from left to right, I'm going to fill out those important positions with those important keywords at the beginning. And then I'm going to figure out maybe the neighbor of this group. After that, I'm going to like keep adding more words so that my sentences become more and more human-like, more and more grammatically correct. So this is one of the ways you can think of it. At the beginning, I have 100% mask. Now I'm going to predict some position. Those positions are maybe like important for you to fill up with the sentences. In the second one, now I have maybe 10% of the word and 90% of the mask. Now I can keep predicting more accurate words so that the sentence will become more human-like. And there will be one day that you have 50% of mass, 20% of mass, 1% of mass. Now you have a human-like sentences. So this is actually a paper published last year. It was not like 10 years ago, 5 years ago, just last year. The paper is titled Simple and Effective, just like the procedure we just see. And the process is called mask diffusion language model, which is saying that I'm going to like uncover a mask with a word. So this is the procedure that in the beginning, then you have a sentence of full mask, and then you have some first model, we call it denoiser, and then you're going to figure out some important word. For example, these two words is review. Now you keep doing it. The second stage, you got this word and this word predicted in the last word. In the last step, you predict all the opposite. Define some relationship of this iterative process of reviewing more and more words with the diffusion model, which is saying that this process from all masks, you can see that all of them are noises, a lot of noises, and then the final answer is a true authentic sentence you want, so it is called a devoid. And the second word, the other direction you can think of it is adding noise, adding more and more noise. An authentic sentence to mask. So you have no clue what the sentence is actually about. One thing that they try to sell is that the procedure you just see can achieve a very good result compared to the a lot of BERT model or language model. They find that the complexity, which is how good some language modeling evaluates. You can think of it. It is evaluated on some testing data. The data was written by a human being. It is going to assign some score, which is saying that this complexity is saying that my model believe these sentences of the human written sentences score. If the score is high, then I have a lot of complexity, a lot of confusion. If the score is low, then I'm almost sure that this is human written sentences. So the evaluation is smaller and better. The smaller, the better. The method they propose that they can achieve a level where in the classic old days that a lot of other modeling, which was very complex. However, the simple way of doing mask and then keep removing mask was an effective method. And the score here was almost comparable to the transformer, which is which people have been working on it for over 10 years. Now, this is just some background about BERT model, and then it's some natural extension. If you are the author last year, you may not find it that is natural because it takes a lot of time for you to do all the experiment and to convince yourself your research is authentic before you have your final experimental result. Now the second part is the student section where we will invite Columbia to present an extension of the BERT model, which is a live BERT for self-supervised learning for language representations. Do you want to have an extension to it?
I do.
Okay,